Welcome to the Automated Daily Space News Edition, the podcast created by generative AI. Today is August 26th, 2026, and over the past 24 hours, the universe has offered up a few surprises, including a new simulation that hints the crowded hearts of galaxies might grow in lockstep instead of in isolation. If you have ever pictured the center of the Milky Way as a chaotic jumble of unrelated structures, today's lead story may nudge you toward a more unified view of how those deep cosmic cores actually come together. U15. I'm Trent Teller, and in this episode, we will walk through FA-E, latest discoveries in cosmology, new views from our biggest space telescopes, and a busy slate of launches and mission milestones that are pushing human hardware deeper into space. As always, the aim here is simple, to give you a clear, engaging snapshot of what changed in our understanding of the cosmos since this time yesterday, without drowning you in technical detail. From star streams shaped by dark matter to compact red galaxies hiding in plain sight, and from stunning new James Webb images to the 100th Falcon 9 launch of the year, we will focus on what happened and why it matters. Chapter 13. Let's start at the very center of the galaxy, where new work is challenging a long-standing assumption about how those dense inner regions are built. U5 This episode is brought to you by Consensus. Consensus uses AI to help you find and understand research papers, and you can get a free month. Find the link in the episode notes. First up today, a new galaxy simulation is giving astronomers a much more connected picture of how the very centers of galaxies assemble over time. A team led by researchers at the Leibniz Institute for Astrophysics, Potsdam, used a high-resolution hydrodynamical model of a barred spiral galaxy to follow the flow of gas and stars into the inner few hundred light-years. And what they saw suggests that nuclear star clusters and nuclear star clusters and nuclear stellar disks are not separate structures after all, diphtenestenes. Instead of forming independently by different processes, the simulation shows that these two components can grow together in a single, linked evolutionary track, driven largely by the galaxy's stellar bar funneling material inward over billions of years. 115. That bar acts almost like a conveyor belt, gradually feeding gas toward the center, where it can collapse into stars that populate both the compact central cluster and the surrounding disk. This matters because for years astronomers have debated whether nuclear star clusters and interstellar disks represent distinct events in a galaxy's history or parts of one bigger story, and the new results lean strongly toward the latter. If the processes are coupled, then reading the fossil record of a galaxy's center becomes more like interpreting a single layered structure, rather than trying to disentangle overlapping, unrelated features, which could simplify how we infer a galaxy's ent from its present-day appearance. 115. It also has direct implications for our own Milky Way, which is a barred spiral galaxy and shows hints of both a dense nuclear cluster and a central disk, suggesting our home galaxy may be following the same script that the simulation lays out. For listeners, the takeaway is that the hearts of galaxies may be more coherent and self-organizing than we used to think, and that major structures there can emerge from one long-running mechanism rather than a patchwork of disconnected events. Staying with the theme of hidden structure in galaxies, another recent result looks not at their centers, but at a ghostly stream of stars stretching out far into space, and possibly tracing the shape of dark matter itself. 03. A team led by University of Copenhagen PhD student Julie Kiel-Holm has identified a stream extending more than 3,000 light-years away from a globular cluster, and evidence suggests this long ribbon of stars has been sculpted by dark matter in a distant galaxy. Clusters are already dense, ancient star groupings, but when their stars are slowly peeled away by gravitational forces, the resulting streams can act like test particles that map the unseen mass around them, making this new discovery a powerful probe of the galaxy's dark halo. What makes this especially interesting is that dark matter, which accounts for most of the universe's matter, cannot be seen directly and must be inferred through effects like this. This third. By finding a stellar stream that appears to have been tugged into its present configuration by dark matter, astronomers effectively gain a new tool to sketch the invisible skeleton that holds galaxies together. In practical terms, that means better constraints on how lumpy or smooth dark matter is on different scales, a key question for understanding both galaxy formation and the underlying particle physics of dark matter itself. It is a reminder that even delicate, tenuous features such as star streams can carry robust information about the deepest, hidden components of the cosmos. The past day has also brought news about some of the smallest and faintest galaxies we can see, which may turn out to be more significant than their appearance suggests. 8. A feature on recent work in Nature Astronomy highlights the so-called little red dots, compact red objects spotted in deep surveys that for some time resisted straightforward interpretation. 8. New analysis indicates that these dots may actually be tiny, extremely dense galaxies whose total mass is around 1 billion times that of the Sun, which is small compared to giants like the Milky Way, but substantial enough to matter for counts of dwarf galaxies in the universe. 8. If that picture holds, then these objects are not just curious blips, but a whole population of compact systems that were previously underappreciated, which could revise how we think about the range of galaxy sizes and densities, especially in earlier cosmic epochs. Their red color suggests old or dust-obscured stellar populations, and their compactness means stars are packed into a relatively small volume, hinting at intense early formation episodes, or later stripping of outer material. UAD. This combination of traits makes them valuable for testing galaxy evolution models that try to explain how small galaxies live alongside giants without being entirely torn apart or having their star formation shut down too quickly. 8. At the same time, another recent Smology feature focuses on dark energy and asks whether it could have gone through phase transitions in the relatively recent cosmic past. 08. By using data on the universe's expansion and structure formation, researchers are able to set limits on how dramatically dark energy could have changed its properties over time, effectively carving out regions of parameter space where certain theoretical models no longer fit the observations. 08. These constraints help bring some order to a very speculative area of physics, where different ideas about dark energy's nature have proliferated without strong guidance from data. 8999. The new work does not yet tell us what dark energy is, but it does tell us more about what it is not, which is a crucial step in refining theories of the accelerated expansion. 8999. Taken together, the compact red galaxies and the bounded behavior of dark energy reflect a broader pattern in current research. As we collect more precise data, we are gradually tightening the allowed range of ways the cosmos can organize itself, from the tiniest faint galaxies up to the overall fate of the universe. Turning from theory to imagery, today's astronomy highlight is a new James Webb Space Telescope view of the Lion's Head Nebula, cataloged as NGC 2092 and known as a planetary nebula created by a dying star shedding its outer layers. 5. The composite image uses JWST's NIRCam and MIRI instruments to reveal the complex structures of gas and dust around the central star, including filamentary arcs and knots that trace how different layers of material have been blown off over time. Invisible leg. HT. Planetary nebulae already look intricate, but the infrared sensitivity and resolution of JWST bring out cooler, more dust-rich regions that might otherwise be invisible, offering a more complete picture of how stars of roughly solar mass end their lives. The explanation accompanying the image directly poses the question of whether we are looking at a possible future of our Sun, since the Sun is expected to go through a similar phase several billion years from now. 5 Circes 5. This connection is part of what makes the image engaging beyond its visual beauty. It is not just a distant, abstract object, but a preview of a stage our own star will eventually reach. By studying nebulae like NGC 2392 in detail, astronomers learn how much mass stars lose, how they enrich the surrounding interstellar medium with heavier elements, and how their death throes influence future generations of stars and planets. 2000 future generations of stars and planets. O helps refine models of dust formation, molecule survival, and the interaction between stellar winds and pre-existing material, all of which feed back into our broader understanding of stellar evolution for CV. For listeners, you can think of this as watching a slow-motion, highly detailed replay of a process that fundamentally shapes the chemical environment in which planets, and potentially life, can arise. There is also a timely visualization of Earth's shadow that ties into an upcoming celestial event many skywatchers will be able to experience later this week. Not 7. A recent astronomy picture of the day shows Earth's shadow as seen through a series of lunar eclipses, stacking multiple images to make the geometry and size of the shadow more intuitive. Not 7. The images reveal the curved boundary of our planet's umbra as the moon passes through it, giving a sense of how the moon's orbit intersects this shadow cone, and why eclipses only happen at specific alignments. This post comes just a couple of days before a new partial lunar eclipse that will occur on the night of August 27 into August 28, depending on your time zone, and will be visible from much of North and South America, as well as parts of Europe and Africa, to 1/17. In that event, the full moon will slide through Earth's shadow so that a significant portion of its surface darkens, with some regions seeing a deep partial eclipse where most of the lunar disk enters the umbra. 1-12 Su. Observers in the United Kingdom, for instance, are expected to see the partial lunar eclipse begin in the early hours of August 28, with the moon moving deeper into Earth's shadow until around 5020 a.m. local time, when roughly 90% of it will be in the umbra before setting as He eclipse ends. For people across the visible regions, this is a relatively accessible astronomical event that can be enjoyed without special equipment, though binoculars or a small telescope can enhance the view of the shadow's edge crawling across the lunar surface. Pouring of the shadow visualization with the upcoming eclipse offers both an aesthetic and educational angle, reminding us that even a familiar phenomenon like a lunar eclipse can still teach something new about our Lynette's place in space. 97. Finally, the last 24 hours have seen a busy slate of spaceflight stories, from routine but high-cadence launches to key rehearsals for future flagship missions. 113 Fortession. Spaceflight now reports on an upcoming Falcon 9 launch from Vandenberg, carrying 27 Starlink satellites, a mission designated Starlink 1049, that will mark SpaceX's 100th Falcon 9 launch of 2026. 100,013 6.113s. Hitting that milestone underscores how profoundly launch cadence has changed over the past few years. What was once headline-worthy or being rare has become remarkable for its sheer repeatability. Not 13s. Each of these flights adds more satellites to the company's growing broadband constellation, which aims to provide global internet coverage, especially to regions underserved by traditional infrastructure. And the rapid tempo highlights how commercial providers are now central players in shaping near-Earth space. Teens. Beyond that single mission, Next Spaceflight notes activity at what it describes as the largest private spaceport in the world, with references to both Falcon Heavy and Starlink flights and, importantly, upcoming test operations for NASA's Space Launch System rocket ahead of the Artemis II mission. And safely drain the fuel, all without astronauts aboard. This kind of full-scale rehearsal is a critical step in validating the rocket's systems and ground procedures before committing to a crewed flight around the moon, helping engineers catch issues under realistic conditions while risk is still controlled. In parallel, the Nancy Grace Roman Space Telescope is moving closer to launch, with agencies and institutions highlighting that NASA is now targeting August 30, 2026 for liftoff, a sheesh. IFT from earlier dates in 2027.24.24. Roman is designed to tackle big questions in cosmology and exoplanet science, including mapping dark energy's influence on the universe and using wide-field imaging to find and characterize distant planets through microlensing and other techniques. Bringing its launch date forward by about a year reflects confidence in the mission's progress and promises to put a powerful new eye on the sky sooner than previously planned, which is particularly exciting in light of all the recent work on dark energy and galaxy evolution we discussed earlier. 2815 elsewhere. On the technology front, coverage has also noted a tiny UK-developed satellite, roughly the size of a small carry-on suitcase, that aims to study the so-called cosmic dark ages, the roughly 150 million year period before the universe's first stars lit up. By targeting signals from that era, such a mission could help fill in one of the most poorly understood chapters in cosmic history, showing how even small spacecraft can see. En tribute to answering very large questions. 3. All told, the spaceflight news from the past day illustrates how everyday launches, careful rehearsals, and innovative small missions collectively push us toward a more complete and nuanced picture of the universe. Thanks to our sponsor, Prezi. Prezi helps you create stunning AI-powered presentations in minutes. Find the link in the episode notes. That wraps up today's journey through the latest space and astronomy stories. From galactic centers that seem to grow in unison, to star streams tracing out the hidden scaffolding of dark matter, compact red galaxies quietly reshaping our census of the universe, and new boundaries placed on how dark energy can behave. The last 24 hours have added several important pieces to the cosmology puzzle. 1923. 838. We also saw how instruments like the James Webb Space Telescope are turning theories about dying stars into vivid, detailed images, and how a simple stack of lunar eclipse, GPSC photos can deepen our appreciation of Earth's shadow just days before many of us see it in person. 5W171. On the hardware side, the 100th Falcon 9 launch of the year, an upcoming wet dress rehearsal for Artemis II, and steady progress toward flying the Nancy Grace Roman Space Telescope all show how human-made machines are keeping pace with our scientific curiosity. If you enjoyed this episode of the Automated Daily Space News Edition, consider sharing it with someone who likes to keep one ear tuned to the cosmos. I'm Trend Teller, and I appreciate you spending part of your day catching up on the universe. Stay curious, stay grounded, and I'll be back with more space news next time.